Good afternoon, everyone. I'm Kevin Gletz. I'm a program facilitator working with Regina District Industry Education Council and Sun West School Division. Today it's my pleasure to introduce Graham Dahl. Graham is a process engineer. He graduated from the US as a chemical engineer and is now employed by Sask Mining and Minerals. Graham's going to tell us about his experiences in engineering and about his new exciting work in Chaplin with Sask Mining and Minerals. Before we start though, the session is being recorded and will appear on the RDIEC YouTube channel for you or others to view in the future. We'd like to request any students who watch this to go to our website at www.rdiec.ca and complete the student survey that can be found on the page. Completion of the survey gets your name in a draw for a $50 gift card. Again, the website is www.rdiec.ca. Welcome, Graham. I'll turn it over to you.
Thanks, Mr. Gletz. So I'm going to talk today about my career as a chemical engineer. As Mr. Gletz mentioned, I'm currently working as a process engineer at a sodium sulfate facility located at Chaplain, Saskatchewan. Hopefully I can shed some light on what a career in chemical engineering might look like. So to summarize my role as a process engineer, I would say that I work to optimize production operations for everything we do at Chaplin. So at Chaplin, we extract sodium sulfate out of Chaplin Lake, and then we process, the raw sodium sulfate into a finished sodium sulfate product that we sell to our customers. In order to optimize the process, I try to increase production by troubleshooting production issues. I work on projects to identify and execute projects to debottleneck different areas of the process or optimize our process by making the process more efficient or increasing production, trying to reduce fuel costs, chemical costs, that kind of thing. And I do research and development. I look to implement new technologies to our process that would create efficiencies or increase production. I'm also responsible for ensuring all the regulatory requirements are met on site with regulators such as the Ministry of Environment and the Water Security Agency. And I help administer the quality management system we have on site to ensure a high quality finished product for our customers. And right now I'm primarily focused on the design and construction of a new SOP facility. So we're actually going to be tearing down the current sodium sulfate facility that we have that was originally built in the 1940s. And we're going to construct a brand new SOP facility. We're going to continue to extract sodium sulfate out of Chaplain Lake, but we're going to combine it with potash that's produced in Saskatchewan to make SOP, which is a specialty fertilizer product. So that was kind of high level what my job description is. Now I'll talk a little bit more about what my day-to-day looks like, what duties I have. So like I said, I'm pretty focused on the new SOP project. So I meet with the engineering consultant firm that we've hired to do the design on a fairly regular basis to discuss project details. As they advance the project, they issue a number of deliverables for the project, and it's my job to review these deliverables and provide feedback or comments on them. These are deliverables such as the design criteria for each discipline, process flow diagrams, specifications, equipment lists, manuals, procedures. There's a long list. And by the end of this phase of the project, they're going to be issuing the piping and instrumentation drawings. I also do a lot of reporting. So this is corporate reporting for our senior management group or regulatory reporting to meet our regulatory obligations. I do production forecasting to try and predict how much production we're going to have for any given year or for the upcoming year, to provide this information to the accountants so they can evaluate cash flows. And similarly, I prepare budgets for the operating expenses and capital budgets that we're going to spend for the upcoming year. I do technical and economic evaluations for any capital projects that we're going to implement. And then a key function of my job is to collect and analyze production data. You can't improve what you don't measure. So trying to optimize our process, it's important that we collect and analyze this data. So for us, that's process data in our production facility or the brining operation data for extracting sodium sulfate out of Chaplain Lake. And so that data collection can be pretty manual. Like you can see my bottom left picture is just a tape measure measuring how open a valve is that's letting water into Chaplain Lake. And then on the bottom right, you can see a process monitoring screen for our current process monitoring system. It's, as you can imagine, it's pretty old plant. The system's not as up to date as our new facility will be. But the key is with the collection and analysis of data is so that we can make informed decisions, data-driven decisions, or if I'm not the decision maker, recommendations to the operations group or just to senior management. So job suitability, what kind of skills will you need to be a chemical engineer? Problem solving is pretty crucial. As I mentioned, there's troubleshooting and operational fires to put out. You'll need to have an aptitude in math, physics, chemistry. Communication and teamwork and collaboration skills are very important. I deal with a lot of different disciplines and departments. I work very closely with operations and the accounting groups and marketing and senior management. So it's important to be able to effectively communicate with all these groups. I do a lot of projects, so project management, and then there's always, as I mentioned, fires to be put out. So there's prioritization of time, and time management is very important. Attention to detail comes in handy when you're trying to solve problems or when you're analyzing a bunch of data. And sometimes you need to get a little creative with problems. If they're in troubleshooting problems in the plant, sometimes they're not obvious solutions, so you need to have some creativity. And lastly, computer skills are pretty important. Computer is the primary piece of equipment that I use. There's lots of specialized software in chemical engineering that you probably use on the job. If there's anything that's more general, I would say it's Excel. I use Excel every day. And if you can become a super user in Excel, you will probably be pretty valuable to any organization. For personality traits best suited, I think a lot of people maybe think of a stereotypical engineer personality, but I would say that it's definitely varies. I know a lot of my colleagues are very different personalities from myself. I've seen a wide range of personalities in my career. But it kind of depends on the position or industry that you get into. You can probably find something where you're a good fit, whether that's a more technical stream, or if you're more suited to managerial positions, or even technical sales, depending on your personality type. Maybe a common theme for personality is someone who is curious how things work, or maybe more importantly, how things can be improved. And you need to be a lifelong learner. That's probably true for any STEM career, because technology and everything is moving at such a fast pace. And I'll also add that if there's any females that are on the fence about engineering because it's a male-dominated field primarily, I just say that when I worked for Devon Energy in Calgary, I was there for 8 years. I had 4 different supervisors over my time, and 2 of them were female, so 50%. And the last team I was on for the last 2 years I was there was a team of 5 people, and I was the only male. So I don't know what the enrollment numbers look like for engineering these days, and I'm not trying to say that there's not an issue with female representation in the field of engineering, but I do think I'm pretty confident that if you graduate with a chemical engineering degree, you'll find an organization where you're a good fit and that probably values a different perspective for the position. So my job is located at the plant site. A lot of engineers do work in head offices, but I work right at the plant site, which happens to be in Chaplin, Saskatchewan. Chaplin's halfway in between Swift Current and Moose Jaw on the #1 highway. And it's just a little mining town that only exists because of the resource extraction that occurs at Chaplain Lake. So in the satellite image, you can see Chaplain Lake. You can see the different divisions that it has. They're all man-made dikes that divide up the lake. And we use solar energy, wind energy, and gravity drainage to concentrate the brine, which contains sodium sulphate in Chaplain Lake. So we transfer the brine around until it gets to center division, and then we can pump it across the highway into one of these 5 reservoirs. And then when the temperatures cool off in winter, the sodium sulphate drops out of the ocean and deposits in the bottom of these reservoirs, and we can drain the remaining brine, again with gravity, back to the lake system. And then the deposited sodium sulphate gets stockpiled right next to the plant using heavy equipment. So you can imagine that when you compare it to other mining operations, this is an extremely energy efficient and cost-effective way to extract a resource. You don't have a bunch of overburden to remove, and you don't have to take any ore and process ore. Our sodium sulfate we deposit is really just sodium sulfate. There's some impurities we have to remove, but not to the extent you would if you were doing another mine operation. Here's a picture of our facility and with the reservoirs in the background. And you can see the stockpile of salt. It doesn't look that big in this picture, maybe from the angle it's on or because it's depleted at the time of the year this picture was taken. But this is where our salt gets stockpiled, and then we use a bulldozer to push it into a hopper where it goes through a crusher for sizing and then conveyed on this belt conveyor into our process facility. And once it's processed, it gets becomes our finished product that gets stored in one of these storage bins and then gets loaded onto a rail car to be shipped to a customer. And this is our office building where I have my office and spend most of my time when I'm not checking things out in the plant. So as I mentioned, a chemical engineer doesn't have a lot of equipment besides your computer and maybe some specialized software, unless you consider the process equipment that we have on site, a chemical engineer's equipment. So this is our flow sheet of our current operation, and we have fairly standard process equipment. Maybe our melter is a little more unique, but it uses a shell and tube heat exchanger to heat the raw salt that comes into the system, melting it into a brine. This brine goes into a 10-foot skimmer tank and a 40-foot thickener tank. It's labeled skim tank, but it's actually more of a thickener tank. And they just remove impurities, remove sand and other things that come out of the lake when we pump the brine. Once it's cleaned up, it goes to an oxidation tank to have hydrogen peroxide reacted with it, and that just removes some of the fish smell because a lot of sodium sulfate gets used as detergent, so you don't want fishy smelling detergent. And then that fully cleaned and nice smelling brine goes to the multiple effect evaporator system, which is, these are our crystallizers, and they again use shell and tube heat exchangers to heat the brine, removing water. They evaporate the water from the brine so that the sodium sulfate becomes oversaturated in solution and precipitates out. So that precipitated solids turn the brine into a slurry, and the slurry gets pumped to a settler tank where it is settled and thickened, and the thickened slurry gets pumped to a centrifuge so that it can be dewatered. And then there's just a little bit of water remaining, and it goes into a natural gas fired rotary dryer where all the water is removed and it becomes our finished product. And the only other piece of equipment on here I didn't mention was the steam boilers, the natural gas fired steam boilers that supply the steam energy to heat the brine in the evaporator system. And here's a block flow diagram of our new process. So I wouldn't be a chemical engineer if I didn't have a little chemistry in my presentation. We're going to take KCl or potash. It's going to be in solution, and it's going to be reacted in a glazerite crystallizer with our sodium sulfate in solution to make a glazerite. Here's this equation here, make a glazerite molecule with a byproduct of sodium chloride. In order to meet product purity specifications, we're going to take some sodium chloride out of the system. We're going to pump our mother liquor from the glazerite crystallizer to the sodium chloride crystallizer to precipitate sodium chloride and remove it as wet cake. And then the solids and mother liquor from the glazerite crystallizer can go into an SOP crystallizer where the KCl reacts with the glazerite to make potassium sulfate, which is SOP, our finished product. And again, we have sodium chloride as a byproduct. So here's a 3D model as an early iteration of our new facility. Now, if you want to build 3D models, you're probably looking more at an engineering technologist or potentially a mechanical engineering degree. But we use this 3D model. It's quite a handy tool, especially when you're talking with interdisciplinary groups to see how everything's going to work together in the new process. So I don't know how to build these things, but I do know how to navigate around them. And it really helps when we have discussions with civil engineering, electrical engineering, mechanical engineering groups, and of course, process engineering groups to come up with our design. Here's another model. This is a METSIM model, which is a little more specific to a chemical engineer. It allows you to simulate the process. And you can try alternate layouts and configurations of the process equipment, and then ultimately calculate a mass and energy balance using this software. So hopefully that's a little exposure to the tools and projects that I work on in my career. Now I just want to talk about the pros and cons of a profession in chemical engineering. As far as rewards of the occupation, I think that it's very interesting work. It's challenging and it's varied. I don't do the same thing every day over and over, that's for sure. I also like chemical engineering or engineering in general because I feel like it's where the rubber meets the road. You know the engineering principles behind what's happening, and then you get to see it happening in the real world in your process facility. The chemistry of the reactions and everything are taking place. In engineering, you also have really no cap on growth with your degree. So there's lots of opportunities for advancement depending on the organization you're in, or the industry you're in. Lots of presidents and CEOs are engineers, and a lot of them have chemical backgrounds. With engineering, you get a professional designation. So after 4 years of work experience, and you submit reports on that experience, you are eligible to get your professional designation, which just means you can put PNG behind your name. It adds some credibility, and supposedly it is a bit of some job protection because you can only do certain job functions if you're licensed with APEX, which is the regulatory body in Saskatchewan. I find chemical engineering to be a rewarding career. You get to facilitate bringing projects to life. You can drive by something that's been built and know that you're a major contributor to that project, and you get to help produce things that hopefully society needs, like fertilizer for producing food or energy that society needs. And lastly, I would say that if you're employed in chemical engineering position, you should have decent financial stability. And I think the degree is a fairly good return on investment, considering you can do it in only 4 years, and you can get a pretty decent job compared to maybe some of the other 4-year degrees or other jobs that would pay as well, but maybe take a little longer to get through the education portion. Some of the challenges with the occupation is that job security is very much tied to the commodity demand. For a lot of engineers work in the resource industry and the resource sectors like oil and gas, potash, uranium, other mining. And over my 10-year career, since I've been out of school, all of those sectors have had major downturns and mass layoffs. That could certainly impact your job security or even your growth within that job or within that sector. Chemical engineering jobs, they are all over the world. I've had colleagues that I've worked with that have spent time in Oman or Norway, but they're not evenly dispersed. So if it's important to you to work in a specific community, you don't find chemical engineers in every community. They're typically in major centers, and they follow commodities industries very closely. Lastly, I'd say that there's definitely a specialization of engineering positions. When you look at job postings, they'll be asking for pretty specific experience or software skills, which I think is kind of unfortunate when you have a chemical engineering degree, and especially if you had some decent experience to your name. I think you've proven that you're capable of learning and could likely excel in any job if you're given the opportunity to learn on the job. But that's probably more of a nature of the job market, how competitive it is. And some bigger companies I found I work for a pretty small resource industry right now or company right now, and I have a huge scope of everything I do, which I really like. If you work for a bigger company, you might have a pretty specialized role in the greater organization. And the last thing I'd say about a challenge to engineering is that it's the education path isn't as practical as it could be or should be, considering how hands-on engineering, how important hands-on training is in engineering. I think it's disappointing that there's not a lot of options for going and getting an engineering diploma and then continuing on to get your degree. You can do it, but it's not that easy or as straightforward as in other career paths. Like when I compare it to my wife is an accountant, she didn't know what she wanted to do after high school. She went, did a 2-year diploma at SAIT for accounting, realized she really liked accounting, and continued on for another 2 years, got a degree, and now she's a chartered professional accountant, same as anyone who went to university for accounting. And her education was probably a lot more focused on what she'd be doing for a living. So I wish that there was more opportunities like that in for chemical engineers. So if you do want practical experience, if you know you're going to end up working in industry as opposed to staying in a more academic path for your career, I would strongly suggest doing a co-op or internship while you're at university. I did an internship, and it was I'm pretty glad that I did it. The salary and benefits for a chemical engineer, I think, are pretty decent. The one nice thing about being part of APEGs is they do a salary survey every year, and you can see what engineers typically make, and they have it broken down into a lot of different or more specific tables of what salaries are. This is a more high-level generic one, but just reading off the chart, a chemical engineer should make, would expect to make between 70,000 and 140,000, depending on whether you're just beginning out or your years experience, your seniority, or whether you got into management and got towards or the upper range that you would expect. The benefits, my experience is primarily with production companies in the resource sector, and so I think they have pretty decent benefits. They have bonuses, drug plans, dental plans, life insurance. There's RSP matching. You might see pension plans in bigger organizations, and if it's a publicly traded company, you probably see stock options, restricted share units, or at minimum share purchasing programs. For holidays, you'll see everything from the standard 3 weeks. But a lot of companies do have a little better holidays. They'll have flex days or vacation purchasing plans, so you can get quite a bit higher than 3 weeks. And typical workday, especially as you're further along in your career, you're going to see 8 to 5 Monday to Friday schedules. If you're in operations like myself, they'll likely be on-call schedules or busy periods of the year, whether it's turnaround or expected to be on call for plant upsets, where you're going to work outside that time frame, and they're typically unpaid overtime hours for chemical engineers. And if you're earlier on in your career, or if you're working very closely with operations, you might have more of a 7 on, 7 off, 12-hour day type of schedule. The education requirements for engineering, I just went on U of S website to see what their requirements were, and they had chemistry 30, physics 30, and pre-calculus 30 as required classes, and requirement for 70% minimum in each of these classes. But then you can go direct entry into engineering and get your engineering degree in 4 years. A lot of people do their engineering degree in 5 because it's a heavy course load. So they have kind of a course load set out for doing it in 5. And if you do a co-op or internship, you'll also take at least 5 years to do get your bachelor's in engineering. And then once you get your degree, you will start in industry as an engineer in training, or EIT. And then once you have 4 years work experience, you're eligible to report on that experience and get your professional designation. And some engineers do go on to get their master's in engineering, or a number of my colleagues have gone back to get an MBA. But these aren't necessarily necessary for advancing in your career. But I'm sure it'd help if you're competing with other candidates for a senior management position. So my career, I went straight from Roseland Central High School into the engineering program because of Mr. Gletz. I knew exactly what I wanted to do. And after first year, I picked chemical engineering for reasons that made sense at the time when I was 19. And I don't know if they would make so much sense to me now, but it worked out in my case. And then when I got to third year, I really enjoyed my time in engineering, but I realized that there was 2 types of engineers: those who knew exactly what they're going to do when they were done and knew what an engineer did for a living, probably because they had a dad or a brother or someone who's in the industry, And then there was at least half, or just like myself, who had no idea what an engineer actually did for a living. I knew that I wasn't going to be able to write tests or do a science engineering paper for money, but I didn't really know. So I came across the engineering program, the internship program at the U of S, and I applied for and got a job with Devon Energy in their head office in Calgary. So that was a 16-month paid internship, which was basically a 16-month interview. So I really enjoyed my time there, and they did offer me a job after I completed fourth year. So I went back to U of S and then went back to Calgary and worked for 6 months out of their head office before they transferred me to a camp position. So I was still living in Calgary, but fly in, fly out to a SEGD facility in northern Alberta, and that's pictured in the top left here. I was there for 2 years, and I really enjoyed my time working alongside operations and getting that technical experience at that time. And then after 2 years, they transferred me back to Calgary in the head office, not by choice, but because they needed to get other EITs experience up at the SEGD facility. So I worked for 6 more years at Devon Energy in Calgary. I came to realize that I kind of preferred working at the plant site over working in corporate Calgary. And at this time, by this time, my wife and I had decided that we didn't want to be in a big center, as big a center as Calgary. Long term, we wanted to move to a smaller community to raise our family. So I started looking for positions outside of Calgary, and then the major downturn hit in the oil and gas industry, and Devon did a bunch of mass layoffs. I wasn't part of the first couple rounds of mass layoffs, but I was part of the third one, which was a really interesting experience, and couldn't have worked out any better for me because it allowed me to go and find a position in Swift Current, which is where we wanted to live. So I got a job with WSP in Swift Current, which is WSP is a massive engineering consulting firm that has a tiny little head office tiny little field office in Swift Current. I really enjoyed. I spent 2 years at WSP in Swift Current, and I really enjoyed my time there. But they focus more on civil and municipal infrastructure type projects, and so my education and my work experience didn't really apply. So it was a bit of a step back in my career. So I was always looking for opportunities that might exist for a chemical engineer, but it'll still allow me to live in Swift Current. And I was actually on parental leave when I came across the process engineering position at Chaplain. And I applied and ultimately got the job starting in May of 2021. So I feel pretty grateful to have found a position that allows me to live in Swift Current. I can't say that there's a lot of chemical engineering jobs that would be around the Swift Current area. And the only reason why this one came available is because my engineering colleague is the only engineer on site. He's 65 and retiring soon, so they need to backfill his position. So the opportunities in the profession are largely tied to the resource extraction industries. At least that's what I'm aware of, is kind of the Western Canada resource extraction. I don't really know what kind of jobs you could find down east or in pharmaceuticals or any other industry like that. I'm familiar with oil and gas, potash, uranium. That's where most of my colleagues and classmates ended up. And they're either working for a producer in those industries, or for a service company in those industries, or a consulting firm, or potentially technical sales in those industries. And I do feel like when I try and keep track of my old classmates, that there is a number of chemical engineers that aren't working as chemical engineers, it seems like. But I'm not sure if that's a reflection of the opportunities or not. There's not a lot of positions outside of major centers for chemical engineers, especially in the oil and gas industry. It seems like they're moving more and more of their field engineers to head offices, and maybe in areas where there's lots of commodity, lots of industry in resource sectors, you can find field positions. But for the most part, you're looking at working or living in a major center. Another thing I would say is, from my experience, all of the jobs I've had colleagues doing this same role that are mechanical engineers by education. So I think you could do most chemical engineering jobs with a mechanical engineering degree. my colleague here at Sask is a mechanical engineer by education. But I don't think it's true. I don't think it goes both ways. I've seen a lot of positions posted that would not consider a chemical engineer. So just my observation, I think a mechanical engineering degree might be a little bit more versatile than chemical, but you'd have to see what the departments are actually posting for their employment rates once you graduate from each program. And lastly, I'd say that, as I mentioned before, there's lots of opportunities for advancement as a chemical engineer. Lots of presidents and CEOs are often chemical engineers. And even though my classmates that aren't working as chemical engineers, a lot of them were able to find really good jobs and maybe even be fast-tracked for management positions in whatever field they get into. So last slide, work-life balance. Can you find work-life balance as a chemical engineer? I think you can. It does kind of depend on the position or the company you work for, what the company culture is like, what your manager, how much of an emphasis your manager puts on work-life balance, because it seems like there's no shortage of work for engineering departments to do. But I definitely think you can find it. Most engineers do work full-time schedules. I think it's really hard to find part-time work if that's important to you. But that being said, it's typically only 40 hours a week and decent vacation packages. So you should be able to find enough time in a year to have that work-life balance. But there are always busy periods and overtime periods that would be expected. So it's not super flexible in that you can, on any given day, decide to take time off. You kind of need to plan it around the busy periods or the project work that you're doing. In my case, I feel pretty fortunate that I was able to find a position that allows me to live where I want to live and live the lifestyle I want to live. We are actually off at 4 every day out in Chaplin, not just because a lot of people do drive, allows us to be home by 5 every night, which is important to me. So I'm at home, I can be a part of my kids' sporting activities or whatever. I'm able to do the things that's important to me outside of work. So that's it. Is there any questions?
It's very well done, Graham. I just, I guess one of the questions I have, and it's more of a comment, like you said, Mr. Galetz, that's me, kind of knew what you wanted to do. I'm not sure I did, but I think you knew what you wanted to do and you went in there. And you kind of said it yourself, like it's so hard to know with so many different kinds of engineering what the actual jobs are. You've really done a great job. I think anybody that watches this today will see what a process engineer, at a resource-based industry would kind of what you would do. We get the gist of it. But what would you recommend for students? Like you said, the internship program was really good, but like how do you decide even to go into engineering? Like now that you've done it and you went through the process as a high school student yourself, because there's so open-ended. Any suggestions there?
Yeah, I do struggle with that myself. I think I knew engineering would be a good fit for me, but I really didn't know what an engineer did, and it was tough trying to pick what discipline to go into. I don't know if I make the same. Sorry.
Did you base that on your kind of aptitude for chemistry, or like when you chose chemistry, or is that something you experienced in your first year that kind of led to that?
Yeah, it went through first year, and I enjoyed a lot of different classes in all the different disciplines, and I did get pretty good marks in chemistry first year. The Peterson twins were a year ahead of me, and I knew I could get my used textbooks from them. So that was one of the factors. So yeah, I just ended up, and I think they put a slide up that showed that chemical engineers had good employment rates and good salaries, probably because oil and gas industry was booming at that time. And so I ultimately picked, and I think if I had to do it again, I might pick mechanical, just based on things I've observed in the industry, but it's not an easy decision. I don't know if I have any good tools, except for it kind of comes back to networking. If you can ever talk to people who are actually working in industry and take any opportunity you can to see what people do for a living. I guess presentations like this are probably pretty helpful in trying to decide what might fit for you. But even as the decision you make in first year, it'd probably be pretty hard to know the person you're going to be 10 years down the road and know what kind of work you like to do, to be perfectly honest.
That's true too. That internship program, is that how many students get to do that, or is that anybody could do it as an engineer, or is it just a certain number?
Yeah, I've kind of heard that like U of A and U of R had co-op programs that were really big part of their programs, and I've heard that it's 50% of kids can do that. I know the U of S's internship program has changed quite a bit since I did it. At that time it was only 16 months. I think they do have more of a co-op style program where you can work 4 months for different employers, which I like the idea of, because you can actually see different roles. Because if you pick a 16-month internship and you don't love that particular role you had, you only got to experience that one role. If you do 3 different 4-month internships or co-op programs, you can see 4 different industries or 4 different organizations. Or
Yeah, that makes sense.
but so I kind of lost my train of thought. What was the original question?
Yeah, about that internship. Yeah, like you said that's what the opportunities are, and I think you just highlighted that pretty well. Yeah. Are there any questions from Renette, Gord, anyone else watching?
When you do an internship program, how much time does it add on to your degree? Like if you choose that route, does it turn into right away a 5-year or 6-year?
Yeah, it typically adds an extra year. So I did a 60-month internship. So you got 1 semester, or I guess 2 semesters, and then the summer on each side of that. And the same would be if you did a co-op program. I believe I think they usually do a 4, an 8, and then another 4-month.
Those are paid work terms though, right? So
yeah, typically in engineering they are paid.
You're taking a year away from studies, but it's not costing you a year necessarily financially.
Yeah, that's a really good scenario. When you do get your final designation, a lot of students I think that once you graduate you're an engineer, but you spoke to that very well. You're not. How does that qualification process work?
Yeah, so it's just a matter of getting the experience that you need that would satisfy APEG's, in Saskatchewan's cases, requirements. So I actually was in Alberta at the time, so I went through APEGA, and you can go on APEGA website or APEG's website, and it'll very clearly outline what you need. But you need to have good experience. I think you need to have typically need to have to directly report to an engineer, so they can sign off on your work experience. I know you can get around that. It's not always the case. I've had classmates that had a little more challenge getting their professional designation, but they were able to because they didn't report directly to a professional engineer.
So are there tests that you have to do?
There's one test, but it's just an ethics exam. It's not a competency exam. It's just an ethics exam.
Okay, thank you.
Anyone else with questions?
I just want to thank Graham too. There were so many things that you addressed in your presentation, not only about the program, but also the path and just some of maybe the questions or the doubts that students may have, in their quest for that job too. So I know I don't actually have a question, but just a big thank you for taking the time. This was awesome.
Yes, thanks so much, Graham. I think we'll end it at that.